Okay, hello everybody. So today we're going to begin our discussion in Chapter 12, Section 7. And that chapter and section deals with probabilities of independent and dependent events. And so you may or may not have already discussed probability in another math class, but what we're going to talk about isn't too difficult and it's pretty straightforward. So let's first talk about what the definition of probability is. So, probability is the ratio of the number of favorable outcomes. Another way of saying favorable outcomes is what you want to happen for the event to the total number of possible outcomes. And what you can see here on this number line is when you write the ratio of the favorable outcomes to the total number of outcomes, you will end up with a number somewhere from 0 to 1 or in between. You cannot have a probability that's greater than 100%, and you cannot have a probability that is less than 0%. So if you have a probability of 0, that means it will not happen. It is impossible. And if you have a probability of 1, it means it will definitely happen without a doubt. So normally probability falls somewhere in between there. As an example, if you had a probability that was 1/2 or 50%, that means that you have an equal chance of that event happening as to not happening. Now, the first thing we want to do is take a look at how to find the probability of finding a triangle. Now, I should back up just for a second and say that there are two types of probabilities. There's probabilities that are dependent and then independent. What we're getting ready to do are independent probabilities. And what that means is that the probability of a second event is not affected by the probability of the first event. An example of dependent probability would be if I chose a student randomly from my class and then picked them to do some sort of task and then chose another student randomly from the class, but that first student would have already been picked and busy. That would be a dependent probability event because there were more people the first time I picked than there was the second time I picked, because that first person that I picked is already busy doing something. So in this case, these are independent events. We're going to treat these as if they're just one pick at a time. So we would like to find the probability of picking a triangle. Now, what you need to do is you need to figure out two things. You need to figure out what you want to happen, which in this case is to pick a triangle, and then the total number of things that could happen. So in this case, you can see we have 3 triangles right here, 1, 2, 3. So the probability of me picking a triangle out of that group is going to be 3 that I can pick from. And I'm picking from a total of 6 objects. And so what you see here then is the probability is 3/6. Now we should reduce that, and they're both divisible by 3. So it gets reduced to 1/2. 1/2, if you would convert it to a percent, would be 50%. So the probability is 1 out of 2 that I would randomly pick a triangle. Now we want to find for number 2 the probability that I would randomly pick a pentagon. Now, if you recall, a pentagon has 5 sides. And if you look right down here, this object right there has 5 sides. So that is a pentagon. However, that's the only pentagon in the group. So when we write the probability, remember, once again, it's what we want to happen, which in this case is to pick a pentagon. There is only one pentagon. And then the bottom number is out of the total number that we are picking from. In this case, we're picking from 6 different objects. So the probability of randomly picking a pentagon is 1 out of 6. So we have 2 more examples here, very similar to the last one. A little bit different in that what they're saying. So for number 3, it says we want to find the probability that we pick not a quadrilateral. So if you remember what a quadrilateral is. A quadrilateral is a shape that has four sides. And so this is a quadrilateral and this is a quadrilateral. So we actually don't want to pick one of those. So what is the probability that we do not pick one? Well, how many of them are not quadrilaterals? Well, you can see there are actually four shapes that are not quadrilaterals. Therefore, when they ask us for the probability of not picking a quadrilateral, there are four shapes that are not quadrilateral, and that is out of a total of 6 shapes. So we would need to reduce that. So it's 4/6. Those are both divisible by 2. And when we do that, we end up with 2/3. Now, the last example like this we're going to try is we want to find the probability of picking a triangle or a quadrilateral. So we need to figure out how many triangles and quadrilaterals there are in our group that we're picking from. In this case, there is only, there are 3 triangles. So we'll put a T for triangle. And there are 2 quadrilaterals. So what that means is there's one object that is not a triangle or quadrilateral. So when they say what is the probability of picking a triangle or a quadrilateral, there are 4 total triangles and quadrilaterals out of a total of, and that is not correct. I said 4. I did not mean to say 4. I meant to say 5. There are 5 total triangle and quadrilaterals out of a total of 6 that we are choosing from. So the probability here would be 5/6. Now, this problem is similar, just like the last one. They want to know the probability of picking a triangle or a quadrilateral. In this case, there are 5 triangles and quadrilaterals, and there are a total of 6 that we're picking from. Here's a triangle or quadrilateral, triangle, 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 quadrilateral. This is the only one that's not. And then the last one says, what is the probability of not a pentagon or a pentagon? So this is very tricky here. So this is saying, what's the probability of not a pentagon? So if we don't have a pentagon, that would be this one, this one, this one, this one, and this one. So there's 4 no pentagons. And then there's actually, that is not true. There are 5 no pentagons. And there is actually 1 pentagon. So what's the probability that I don't pick a pentagon or I do pick a pentagon? And what you have to realize is by saying that, we're actually qualifying all of the shapes here. So you can pick any shape you want. What's the probability of not a pentagon or a pentagon? There would be 6 total shapes that are not pentagons and are pentagons out of a total of 6. That would give us 1, which means there is a 100% chance that the shape we pick is either not a pentagon or is a pentagon. Now, the next type we're going to look at is more of a word problem where they give us a certain number of different objects, and it's our job to come up with a probability if we would randomly pick one. Now, what these types of problems don't typically do is give us the total number of things we're picking from. So usually you have to calculate that first. So in this example, it says school carnival. Ring toss game has bag of prizes containing 4 sunglasses, 6 hairbrushes, 5 keychains, and 10 stuffed animals. And they ask you to find the probability of each of these. So first we need to total up how many objects we're picking from. In this case, we have 4 plus 6 plus 5 plus 10. Now, if we do add all those up, we end up with 25. So there are a total of 25 objects that we are picking from. 4 plus 6 is 10. 10 plus 5 is 15. 15 plus 10 is 25. So now they want to know, first one, the probability of picking a hairbrush. So if we go here and we look, we can see there are 6 total hairbrushes in there. So if I write how many total hairbrushes there are 6 out of a total of 25 objects we are picking from. So there is our probability of picking a hairbrush. Now they want to know, for the part 2, what is the probability of not picking a keychain? So in other words, anything but a keychain. So let's look at what is not a keychain. We have 4 sunglasses, 6 hairbrushes, and we have 10 stuffed animals. Those are not keychains. So how do we account for all that? Well, you have to add all those numbers up. So 4 plus 6 is 10, and 10 plus 10 is 20. So there are 20 objects that are not keychains. Now, how many total do we have? In this case, once again, we still have the total of 25. Now we're left with 20 over 25, which is your probability, but it's not in simplest form. So we would want to go ahead and divide both of those by 5. And when we do that, we end up with 4/5. And there's your probability for number 2. Now, this is very similar to the last one. In fact, it's the exact same scenario. It's just 2 different probabilities. So it says, what is the probability of picking a sunglasses or a keychain? And that is incorrect, what I just said. Okay, so for the next example, for practice number 2, we have the same scenario. We have 4 sunglasses, 6 hairbrushes, 5 keychains, and 10 stuffed animals. But for this particular one, we are actually going to make 2 picks instead of 1 from the single group of items that we have to pick from. Now, this is a case where we have dependent probability. And dependent probability would be a multiplication problem on top of the regular probability, which I will show you how to do right now. Now, how do we know it's dependent probability? Well, what we're doing is we're actually making 2 separate picks. The first pick, they want to know the probability of picking sunglasses. Then they want to know what the probability would be to, after you pick sunglasses, to pick keychains. And so this is a kind of a compound event, and the second event depends on the first event and what you actually pick. So let me show you how to do this. There are 2 different probabilities for this that will get multiplied together. So first we need to find the probability of picking a sunglasses, which there are 4 sunglasses out of a total of 25 objects. Now, the next part to this is, what is the probability of picking a keychain? Now, here's the thing you have to remember. Once you pick your sunglasses, you have to assume that you did pick a pair of sunglasses, which means there are only 3 sunglasses left, and there's only a total of 24 items left because you took 1 item out already. So now when I go to pick the keychains, there are 5 keychains left, but we are only picking from 24 objects because we already picked the first time, pulled a pair of sunglasses out. So again, this is called a dependent probability because the second pick probability is affected by the first pick because we picked something and took it away. Now, when you have these compound events like this, or dependent probabilities, you need to multiply the 2 numbers together. So in this case, when you multiply fractions, it's top times top, which gives you 20. And then on the bottom, you have 25 times 24, which we can do right here on my calculator. And you can see we get 600. So we end up with 20 over 600. Those are both divisible by 20, which means you get 1 over 30. And that is your probability of randomly picking a pair of sunglasses and then randomly picking a keychain after that. Now, number 4 is a little bit different than the last one because it doesn't say pick SA or HB, SA being stuffed animals or hairbrush. So you're picking one or the other. You're not taking 2 picks like you did in the last problem. So we just need to figure out how many totals, stuffed animals and hairbrushes there are, and then we'll know what our probability is. So we can pick a stuffed animal, which there's 10 of those, or a hairbrush, and there's 6 of those. So there's a total of 16 objects that we would be okay with picking. And that is out of a total of 25 objects. And so in this case, our probability is 16 over 25. So I have one more example to show you. And this one is like two examples ago where we have a compound probability. These are dependent probabilities because we're making multiple picks. And as you can see in this one, we're actually going to pick three different things. But let's start with number 5 here. So same scenario, we have 4 sunglasses, 6 hairbrushes, 5 keychains, and 10 stuffed animals. And we want to find the probability of not picking a stuffed animal. So in other words, what objects or how many objects are not stuffed animals? So that would be sunglasses, hairbrushes, and keychains. So there are a total of 4 sunglasses and 6 hairbrushes, which gives us 10, and then a total of 5 keychains, which gives us a total of 15. So 15 out of the 25 items would not be stuffed animals. So that's our first pick. Now, our second pick, because it's a comma, they want to know what the probability would be to pick sunglasses. Now, remember, you have to think of these terms in terms of you've already successfully picked something that is not a stuffed animal. So you've taken it out of the group. We started with 25 items, but now that you've pulled one thing out, there's only 24 items left. So whenever we go to make the probability for the sunglasses, we would say, okay, there are 4 sunglasses, but there's only a total of 24 items left because that first pick picked something out already. So now that we have both of the fractions, because this is a compound probability, you need to multiply both of those together. And as we did before, we will multiply the top and the bottom. 15 times 4 is 60. And then 25 times 24 is once again 600. Now, both of those are divisible by 60, and you end up with 1 over 10. So your probability of picking something that is not a stuffed animal, followed by picking a pair of sunglasses, would be 1 out of 10 chance. So the last one I'm going to show you is actually a compound event where there are 3 picks that happen. And so they want to know what the probability is first picking a stuffed animal, and then picking a hairbrush, and then lastly, picking a pair of sunglasses. So because we're picking in a row from the same group, you're going to see why these are called dependent probabilities, because the first pick affects how many you're picking from the second time, and the second pick and the first pick affect how many you're picking from for the third pick. So what we will do here is figure out the probability of picking a stuffed animal. There are 10 stuffed animals out of a total of 25 items. The next pick we want to do is we want to pick a hairbrush, and there are 6 hairbrushes left. But remember, we've already picked one stuffed animal out of at least those 10. So there's no longer 25 items left. If we've picked one out, there are only 24 items left. Now, the last probability here is the probability of picking a pair of sunglasses. And there are 4 pairs of sunglasses here. But once again, if we've already taken 2 picks out of the total, we started with 25 items, but we've taken 2 items away from that. We are now left with only 23 items to choose from. So we have the probability of this picking a stuffed animal from when we haven't picked anything is 10 out of 25. And then once we've picked one thing out of our group, we only have 24 left. And we want to know what the probability is picking a hairbrush. There are 6 hairbrushes out of 24 items, and we pick that out. And then lastly, we want to know the probability of picking a pair of sunglasses. And there are 4 pairs of sunglasses left, but there's only 23 total items that we're picking from. And now to do this, we're going to do the same as we did in the last couple problems. You're going to multiply straight across. And so whenever you do 10 times 6, that's 60. And then 60 times 4 is 240. And the last one is 24 times 23 times 22. We will do that on our calculator. So let's go with 25 times 24. Whoops, we got to get rid of that. Let's do this again. 25 times 24. So messing us up here. Let's try this again. 25 times 24 times 23. And we get 13,800. 13,800. Now, we should reduce this if it's possible. You can see that they both definitely end in a zero. So we can cancel out the zeros there, and we end up with 24 over 13,080, or I'm sorry, 1,380. And they are both even. So they'll at least be divisible by 2. They probably are divisible by 4 as well. And 3. So I'm saying 12 will go into both of those. Let's see if we can divide both of those by 12. I know 24 is divisible by 12. 24 divided by 12 is 2. And let's see if 1,380 is divisible by 12. 1,380 divided by 12. And you get 115. And there we go. So there's the reduced fraction. It would be the probability of picking a stuffed animal followed by a hairbrush followed by a sunglasses would be 2 out of 115. So I hope that made sense, guys. As always, if you have any questions, feel free to email me. Have a great day.